At Array of Stars, virtual reality is more than a solution for clients, but is a key part of our design and production process. With it, we can quickly prototype ideas and explore how they feel before they've been built. We virtually reconstruct the spaces we're designing for, so we can spend more time integrating end product and show concepts at full scale to clients and team members alike. Everything we learn from our VR prototypes informs and refines our work. And recently, we partnered with Professor Michelle Louis, who's employing VR powerfully for education and research at the University of Toronto.
I am Michelle Louis. I am a postdoctoral fellow at the University of Toronto, Mississauga. My PhD is in education from the University of Toronto. I'm also affiliated with KMDI, the research cluster that is in the iSchool at St. George, and I primarily coordinate virtual reality research for the lab. If you're learning abstract information, it really helps for you to manipulate something that's physical. Cognition isn't only in your mind, it's also in the body and environments around you. So how does learning occur when you are in VR, and how is your body involved? We know you can transform your users and have them be in separate spaces. What can you do in terms of learning the more complex, hard to learn, difficult to teach concepts?
One of these hard to teach concepts inspired the development of MOLGEN, a VR simulation that shrinks students down to the size of a single bacteria. Here, they can interact with molecules up close, examine their different behaviors, and learn how the system works by participating in the process within the environment.
I worked with Rhonda McEwen. Rhonda and I were both interested in VR and the idea that the body and cognition are connected. And my collaborator, Martha Malali from Carleton University, just finished teaching microbiology and a concept known as the lock operon. It's what we call a complex system, what we learning scientists call a complex system, because it's not just a process happening. It changes. Really hard to get students to dive deep into those processes and how it all changes. You want to get in there, you want to play with it. So we go, okay, let's think about how a simulation and how VR can be useful. You want to be able to see the genes around you. You want to see the lactose coming in and make the connections that when the lactose come in, this happens. And this is the kind of thing that students get to do within the bacteria in VR.
MOLGEN was designed to be used in the lab, with a researcher operating the simulation and capturing data from participants. This data will be studied to help researchers understand more about how people learn while in VR and how to design better learning tools for students.
The students that were participants of this research were the core students of my collaborator. And so they were in VR as part of their curricular context. So even though they were in the lab and I strapped sensors on them, I see their learning as part of their experience with that course. I'm always trying to get into, I want to say, the head of the people who are in the design spaces and what they're thinking, what they're doing. You hear a lot of, ooh, oh my goodness, I never thought about that. And then on the other side, there are absolutely students who get overwhelmed by all of the VR objects in the space. And to have that kind of data as they're learning this complex system, because they want to learn about it and because it's part of their education, it's an important data point for researchers to figure out, well, not only how do you design for VR, but how does that translate to their learning in the real world?
But in March of 2020, COVID-19 forced all in-person activities at the university to cease, including research around VR learning.
It is so hard to stare into a Zoom screen from 8:25 until 2:45 all day. It is so hard to get them involved in their own learning. If we can involve more active forms of learning, For example, even introducing VR simulations in some cases to address these problems.
So in May of 2021, Michelle approached Array of Stars to port MOLGEN to mobile VR headsets, allowing students to bring the simulation home and operate it on their own time.
And to port it to mobile, what it means is that it is more accessible. More students can use the Quest headset. This class, they don't have a lab. So if they can get lab or hands-on learning time using the VR headset in a collaborative setting, that would be perfect.
Now, the MOLGEN simulation is available through a device that fits in a small bag and can be set up anywhere with no cable, computer, or additional operator. And with the addition of hand tracking, students can choose to put down the controllers and reach out to grab the molecules using only their hands.
The role of the body in learning extends to how you're using your hands. And there is a theory that the more naturalistic motions are less cognitively demanding. So it is one idea in which we're pursuing to see, well, how does it work for somebody who is in VR, looking at a lot of different objects and trying to make sense of something that is fairly complex, whether that part of their body is an important piece to how they're making sense of the world, their world, the bacterial world around them. And then the research tells us not only whether the VR simulation worked for the students, but also how it might inform theories of learning so that we can design new curricula for learners and figuring out how to interact with your entire body, which we're not used to.
It's like, instead of watching Magic School Bus, now you're on the Magic School Bus, right?
That's exactly the inspiration for a lot of the work that I do.